Before the launch, several engineers warned about a serious problem. They believed the shuttle should not fly that morning, but the countdown continued. 73 seconds later, the entire world understood why. January 28, 1986, Cape Canaveral, Florida. It was an unusually cold morning, but the sky above the launch site was perfectly clear. Thousands of people gathered to watch the launch. Families, journalists, and space enthusiasts stood together. They were waiting to see the Space Shuttle Challenger rise into the sky. For many Americans, shuttle launches had become familiar. Over the years, the program had completed several successful missions. The Space Shuttle represented the future of space exploration. Reusable spacecraft, frequent launches, a new era in technology. But this mission felt different. Among the 7 crew members was Krista McAuliffe. She was not a career astronaut, she was a high school history teacher. Krista came from Concord, New Hampshire. She was 37 years old. She had been selected from more than 11,000 applicants. The program was called Teacher in Space. The idea behind the program was simple and powerful. NASA wanted space exploration to feel closer to ordinary people. Krista McAuliffe would become the first teacher to travel into space. From orbit, she planned to record several lessons for students. Millions of children across the country were preparing to watch, but the mission had many scientific goals as well. It was officially known as STS-51L. The crew planned to deploy a communication satellite called TDRS-B. This satellite would improve communication between spacecraft and mission control. Another experiment involved observing Halley's Comet, which was passing through the inner solar system. Several other experiments were also scheduled during the mission. The crew was experienced and well-trained. Commander Francis Scobie led the mission. Michael Smith served as the shuttle's pilot. Mission specialists included Judith Resnick, Ronald McNair, and Ellison Onizuka. Payload specialist Gregory Jarvis was also part of the team. And finally, Krista McAuliffe joined them as the teacher in space. The launch had already been delayed several times. Weather conditions had forced earlier postponements. Technical checks also slowed the schedule. Finally, January 28th was selected as the new launch date. But during the night before launch, temperatures dropped sharply. For Florida, the cold was unusual. Ice formed on parts of the launch structure. Engineers inspected the shuttle carefully. NASA managers reviewed the situation. Eventually, they decided the launch could continue. The countdown moved forward. By late morning, everything was ready. At 11:38 a.m., the engines ignited. Flames erupted beneath the shuttle, and Challenger slowly lifted from the launch pad. The spacecraft climbed into the clear blue sky. A bright plume of flame and smoke followed behind it. Crowds near the launch site cheered loudly. Television cameras broadcast the moment across the United States. In many schools, students gathered around televisions. They watched their teacher begin her journey to space. At first, everything appeared completely normal. Mission control in Houston calmly reported the flight data. The shuttle continued gaining speed and altitude. From the ground, the launch looked smooth and perfect. But inside the system, a small technical problem had already begun. The space shuttle relied on 2 massive solid rocket boosters. These boosters produced most of the thrust during launch. Each booster was built from several segments. Where those segments connected, engineers installed rubber seals. These seals were called O-rings. Their purpose was simple but extremely important. They prevented hot gases from escaping during ignition. Engineers had raised concerns about these seals before. On several earlier missions, they had noticed small signs of erosion. The problem had never caused a major failure, but it remained a known engineering risk. The unusually cold temperature on launch morning worried some engineers. Rubber becomes less flexible in low temperatures, and flexibility was essential for the O-ring seals. The night before launch, engineers held an urgent discussion. They spoke with NASA managers during a long conference call. Some engineers recommended delaying the launch. They believed the low temperature might affect the seals. Managers asked for clear evidence that the launch would be unsafe, but the engineers could only show warning signs, not absolute proof. After several hours of discussion, the launch was approved. The countdown continued as planned, and the following morning, Challenger lifted into the sky. But less than a second after liftoff, something unusual happened. Cameras later revealed a small puff of smoke near one booster joint. The cold O-ring seal had not fully sealed the gap. Hot gas briefly escaped from the joint. For a short time, debris from the burning fuel blocked the opening. This temporary blockage prevented further gas from escaping. To observers on the ground, everything still appeared normal. The shuttle continued climbing higher. Mission Control continued reporting standard flight data. But the situation inside the booster joint remained fragile. As the shuttle accelerated, it approached a critical moment in flight, a stage known as maximum aerodynamic pressure. This is when air resistance places the greatest stress on the vehicle. At that moment, strong winds pushed against the shuttle. The temporary seal inside the booster joint failed. A flame began escaping from the side of the booster. The flame pointed directly toward the large external fuel tank. This tank carried liquid hydrogen and liquid oxygen. These substances powered the shuttle's main engines. Within seconds, the flame damaged the structure connecting the booster and the tank. The system began to lose stability. Aerodynamic forces increased rapidly. 73 seconds after launch, the situation reached a critical point. The external fuel tank lost its structural integrity. Large amounts of propellant were suddenly released. The shuttle structure broke apart under intense aerodynamic stress. From the ground, observers saw a large expanding cloud in the sky. The two rocket boosters continued flying briefly before separating. Across the country, millions of viewers watched the launch unfold. In Houston, Mission Control soon realized that contact with the shuttle had been lost. What began as a moment of excitement had suddenly become a national tragedy. The United States entered a period of mourning. Later that evening, President Ronald Reagan addressed the nation. He spoke about courage, exploration, and the risks that come with discovery. A special investigation team was formed. It became known as the Rogers Commission. The commission included scientists, engineers, and astronauts. Among them was physicist Richard Feynman, a Nobel Prize winner. The team studied thousands of documents. They analyzed telemetry data and engineering reports. Their goal was to understand exactly what happened. During one public hearing, Richard Feynman performed a simple experiment. He placed a small piece of O-ring material into a glass of ice water. After a short pause, he compressed the rubber with a clamp. When the clamp was removed, the material stayed stiff. The cold rubber did not return quickly to its original shape. The demonstration clearly showed the problem. Low temperatures affected the seal. The investigation revealed deeper issues as well. Communication between engineers and managers had been flawed. Safety concerns had not received enough attention. The shuttle program was suspended for nearly 3 years. During that time, NASA redesigned the booster joints completely. New safety procedures were introduced across the program. When shuttle flights resumed in 1988, the program had changed. Engineering oversight was stronger, independent safety reviews were introduced, communication channels were improved. The lessons from Challenger reshaped the entire space program. They also influenced safety practices across the aerospace industry. The 7 crew members of Challenger are still remembered today. They represented courage, curiosity, and dedication to exploration. Their mission inspired millions of students and future scientists. Space exploration has always involved risk, but every mission also brings knowledge and progress, and every lesson learned helps make future exploration safer. The story of Challenger remains one of the most important moments in space exploration. It reminds us that technology alone cannot guarantee success. Exploration also depends on careful engineering, clear communication, and respect for risk. Humanity continues to reach toward the stars, and the lessons of Challenger continue to guide that journey.